Friday's notes to begin 1-4, we had solve equations, solve problems by writing equations. Did a little bit of both of those things. And now my smartboard has to wake up. Yeah. It's a word problem, but it's not, right? I mean, they give you a picture with it and everything, so yeah, it's a word problem, but we're still not doing really super duper challenging word problems. They're giving us a little bit to help us along in there. And we also talked about how during the process of solving equations, you can get something super weird, like 3 equals 7. And you go, no, it doesn't. And that means it doesn't have any solutions when that happens. Or you can get something that always makes sense. 5 equals 5. All the time means it has infinitely many solutions. Most of the time, we like it when we get one answer. You know, we like it when we get x equals 7, x equals 25, you know, those type of things. But we don't write the books, so we don't know until we solve it whether or not we're going to be able to put x equals something. And then we get here. And this is where we're going to start today. And this is called literal equation. The word literal tells us, the definition of literal has to do with the fact that it's kind of a duh moment. Like I come over here and I say, there's a desk right in front of me. Yeah, duh, it's right there. But usually it has to do with, you know, some little sayings that we know the sayings, we know how they're supposed to work, but they're not actually exactly as they are. I'll give you an example. Somebody says, I'm in a bind. We don't run and call the police and say, oh my gosh, my friend is all tied up. They're bound. They said they're in a bind. Well, in a bind is meaning I'm busy, I've got all these things going on, and I don't know how I'm going to handle it. That's not literal, you know. They're not literally bound up somewhere and kidnapped and all that good stuff. But literal is, it's right there, I can see it, and it's happening. And that's what we're going to do with our literal equations. An equation that uses 2 different letters as variables. One to start off with, I wanted to make sure everybody recognized. That's the area of a circle. Area equals pi r squared. Now, the question is this equation literally solved for A, or is it literally solved for R? And the answer is, well, which variable is all by itself? Because that's what it's literally solved for. So this one is literally solved for A. Now, what does that mean? It means that I could give you this very long list of radii of circles and say, here you go, find the area for me. And you'd be pleased as punch because you'd say, well, get me a calculator and I can do that in no time. Because all you do is put it here, square it, and take it times pi, and boom, you have your answer. However, let's just say I decide to be difficult. And I give you circle areas and ask you to work backwards and figure out what the radius is. Well, if you have to do a lot of them, you don't want to put it in here every time and substitute it and then do your division and all that. You want to solve that formula for R. Get R by itself. Because then it's calculator work. Punch it in. So I started thinking, this means I'm going to have to move stuff over if I get R by itself. That's using inverse operations. That's undoing. Let's see. That means I have to use, please excuse my dear Aunt Sally, backwards when that happens. So, anything that's being added or subtracted to R, I'd have to move over first. Nope. Anything that's being multiplied or divided times my R, that's my next step. Oh, pi. This is multiplication when they're sitting right next to each other. I'm going to divide. Move it over. A over pi equals R squared. So I checked add and subtract. I checked multiply and divide. Now I'm at exponents. Undoing squaring something. Square root. That's what that's for. So we'll take the square root of both sides. And normally that would mean that we have to put a plus or minus on it. but this is a radius of a circle. Can't be negative. Can't be negative. So this formula was great if you wanted the area. This formula is fantastic if you want the radius. So what we just did was we took an equation that was literally solved for A, and we made it an equation that is literally solved for R. And it just has to do with what are you being given and what do you want. So now in problem 5, this one says, the following equation relates temperature in degrees Fahrenheit, F in degrees Celsius. What is F in terms of C? C equals 5/9 times the quantity F minus 32. Oh, well, what are they asking me to do? What is F in terms of C? That always seems to mess people up because they're like, so does that mean I'm supposed to solve for F, or does it mean I'm supposed to solve for C? Well, look at the problem. What is it already solved for? So would it make sense that they would say to solve it for C? And they didn't. You could stop reading right here. What is F? That's what we have to find. We've got to get F by itself. Now, our brain says, because we're taught this all the way through exponential, distribute the 5/9 and then start moving things over. We can do that. It'll work if we do it right. But I really start thinking, but the goal here is to get that by itself. So can't I just move that 5/9 over? You can. But what you can't do is then follow the order of operations backwards. You have to think more about what you're doing. So normally we'd say, I'm going to divide both sides by 5/9. Oh, wait a minute. Can't do that. You can't divide fractions. You have to multiply by the reciprocal. So I'm going to multiply both sides of this equation by 9/5. I wrote it all up there so everybody can see. Oh yeah, over here we've got the Christmas colors, red and green, and over here we've got the Christmas color, red. Well, look at those two. Red and green are going to cancel each other out. That's why we multiplied by the reciprocal. So we have 9/5 C equals F minus 32. Now remember, we could have distributed this and then followed the order of operations backwards also. But I'm guessing most of you would rather not work with fractions all the way through something if you didn't have to. So this is probably the easier way to go. We are so close. We're like this close to being done. This has to go. How do you suppose we get rid of subtracting 32? What should we do? Add 32. Let's add 32 to both sides. Nine-fifths C plus 32 equals F. See, Jerome, can we put that 9/5 C and that 32 together? No, they don't have the same variable. They both need C to the first in order for us to put them together as like terms. So, no dice. But we did it. There it is. This was literally solved for C. This is literally solved for F. We did exactly what we needed to do. Well, this one looks pretty basic. Solve the equation for K. There's quite a bit of gunk over there on that left-hand side to get rid of. You see any parentheses? So we can follow the order of operations backwards then. If anything's being added or subtracted, use its inverse to get rid of it. How are we going to get rid of minus 2z? Add 2z. Let's add it. I'm writing 2z plus 12. You could write 12 plus 2z. It doesn't make any difference. Oh, now we're really close, right? What operation is it when a number is right next to a variable? What does that mean we're doing? Multiplying. How do you undo multiplying? You divide. I always put an extra line through my z's so they don't look like 2's. But this one, we're not done. Because I look at 2 and 12 and 6 and I think I could take out of all of them exactly. To do that, I really want to reduce and or cancel. Canceling is a form of division. So if we're going to cancel, we have to see multiplication, which means I'm going to have to write it like that. So now I have to figure out what would go in the parentheses. Anybody know the fancy name for pulling that 2 out of there? Starts with an F. Factoring. Yeah, we're factoring out a common monomial factor. Pull out the 2. Now we see multiplication. Because when a number's outside parentheses, that's multiplying. Hey, we can cancel. So we can take 2 from the top and the bottom. And there it is. K equals z plus 6 over 3. Now the next one is where sometimes people lose it a little bit. They're taking out all the numbers. No more numbers, only variables. Don't let it freak you out. Solve that for x. You know what makes a great mathematician? The ability to say, if I could just make that look like the problem I already know how to do, then this will be a piece of cake. How do I make this look like these? And I realize, well, this one has x in 2 spots. If I can get x in 1 spot, I can do this. I know what I'm doing if I can get x in 1 spot. So what I want is x and something. Ideas, it's something we just used. Factor it. Yeah, let's factor the x out. Now we can get x by itself, because this is being multiplied by a minus b. If we want to move that over to the other side, what's the inverse of multiplying? Let's divide both sides by a minus b. X equals c over a minus b. So it was all variables, but it wasn't that complicated. I mean, we just have to figure out, how do I get the variables that I need on one side, and how do I separate them from the rest of this? And at this point, in any normal year, I would pair you up and say, go do number 7 and number 8 together. But I'm going to have you help me out a little bit more. I want everybody telling me what we need to do in these problems. We'll just all work together. Take a look at problem 7. Do you see how that's really close to what we just did in the last problem? But there's one more step we have to do to get it to look exactly like the last problem. What is that one step? Move the TU over, right? Because then they'll both have the U. Well, that's easy enough. This is minus TU. I'm going to add TU. Now it looks just like the problem we just did. So this time we have to pull a U out. Remind me again, how are we going to do that? Yeah, we're going to factor out that U. I Again, it's all variables, but don't let that freak you out. Now we're super close. How do you get u by itself? Divide. U equals negative w over v plus t. Not my favorite variables, by the way. Some people's u's and v's look too much alike when they go through. 8 looks harder. One of them has 3 variables. Ah! What would you do first? What would you do? With explanation also. Very impressive. Love it. So he said, I'm going to take this bxy, subtract it over here, because then I'll have my x's on the same side. Beautiful. Now we have everything on the same side. Somebody want to help out with the next step? I could see you're all doing it. Can't somebody just tell us what they're doing? Okay, Lucy, what'd you do? I saw you finish this up pretty fast. Yeah, you factored out that x. Oh, I don't want that to look like division. It's got a little drop of something there. So we factored it out. Alistair, close to done, right? What's left? Yep, by this little mess right here. Gonna let you in on a secret. This on the test is often one of the toughest problems for students to do. Do you feel like this is the toughest thing you've learned so far this year? Okay, so I want you to put a great big star by this stuff so you remember. Senior Home said people mess up on this when we get to the test, because I always wonder why. I mean, we're doing this in class and everybody's like, move it all over, factor, divide, and you've got it down, and then we take the test and people go, huh? So remember, star, study this. Because we are going to take the test on the 22nd, and we had said, we had our PLC on Friday, we had said, you know, if you're not in class on the day of the test, you'll just take it the next day. Well, that's not going to work, because we were doing the schedule, and what happened was one class, I think it's you guys, were here right when you needed to be taken. No, it was B. It was the B day students. They're here right when they need to take the test. And you guys have like 4 days before you come back and take the test. That would be bad. I don't know if you've ever been gone for 4 days after the class has taken a test, but that does not go well. So we decided with this first test, since it's so much review, everybody's going to take it on test day. So even if you're distance learning, we're going to have a test on distance learning for you to take and get that done. We don't want anybody to have an advantage because they were in class versus not in class. So we're not sure whether or not that's going to happen again, but we just can't have one group taking it and another one having too much time to forget before they come back and take the test, especially since tests are 80% of your grade. Yeesh. 2 more. Looks like a word problem, but we should know, hey, it's not really a word problem because we're just focusing on the equation. The equation K equals C plus 273 relates temperature K kelvins and degrees C Celsius. What is C in terms of K? What are we trying to get along? Yeah, so you just stop reading right here. What is C? I mean, that's what we need to know. Wait a minute. Isn't this much easier than the stuff we just did on the last page? It is. Every once in a while you get one where you go, oh my gosh, I can't believe they're having me do that. What's our one step? That's it. Subtract 273 from both sides. And of course, k to the first and 273 are not like terms. So there it is. That's our formula. Now the reason they gave us this is because they want us to think about what just happened here. Is the equation relating temperatures in kelvins and degrees Celsius, is that always, sometimes, or never true? So, if I tell you that that is absolutely true, what will you say about this red one that we just developed? Did we use rules of algebra to get it? Then we did not change what's called the truth and falsivity of the statement. It's still true. That's why they're called equivalent. They may look different because it's literally solved for K and then it's literally solved for C, but they will both always be true if we have done everything correctly. That's 1-4. So, if you could grab your yellow sheets. And fill out your rating after the lesson for I can solve equations and I can solve problems by rating equations. That would be fantastic. You guys were doing great. Some of you are going to be very close to finishing this assignment before you get out of here. So if you finish your assignment, don't forget to go back and rate yourself after you finish the assignment. So that was Friday's. This is today's. But you were doing absolutely great. Like I said, this one, it always boggles me when we get to the test that people make mistakes, because when we're in class and everybody's learning this, they're like, yes, I got this. I do know that sometimes when people think something's too easy, they don't do the homework. And we all know that is a huge mistake. Huge.